Hey guys, I'm going to do a quick Leetcode problem for today's video. This is Leetcode problem number 33, search in rotated sorted array. One of the first things I notice with this problem is that the array is already sorted, so we don't have to sort ourselves. So at best, this might be an O of n operation, possibly a log n time complexity because it is array sorted. If we had to sort it, it could possibly have been linear rhythmic time or O(n) log n time. But since it's sorted, we might be able to solve it sooner. So suppose an array sorted in ascending order is rotated at some pivot unknown to you beforehand. Oh, let me start the timer too. Is rotated at some point unknown to you beforehand. For example, 0, 1, 2, 4, 5, 6, 7 might become 4, 5, 6, 7, 0, 1, 2. You're given a target value to search. If found in the array returns index, otherwise return -1. You may assume no duplicates exist in the array. Your algorithm's runtime must be complete in order of log n. So what this is telling me is that it would be very useful to actually use binary search. And even though it's shifting, everything's sorted, so you can kind of just divide and conquer this array and how it's being resorted each time, piece by piece. So let's see. I wonder if it resorts like every single time. I don't think it does, but I only think it resorts one time. So from there, what we could do is I'm going to do binary search, some type of algorithm like that. It's going to be modified binary search that will get us our O log n time. And I believe we can do this with O constant or O1 space because we're just doing variables here. So this list is resorted and we have our target value. So let's do left equals 0 and right equals lang of nums -1. And then what we can also do is we can have our lowest value and our greatest value and track those indexes. I think that might be useful as well. So lowest value. And let me just make sure that that would be O of n times. So we wouldn't want to use that because that would overpower the log of n times. So never mind. Then we'll have a middle. So basically you're just combining the right index plus left index and then doing a floor divided by 2. So from there what you could do is so let's look at that right here. This semi-sorted array. So from this you would be right here. Okay, so that would be left, this would be mid, and that would be right. Okay, so from here, mid would be 7, right would be here, left would be here. Okay. So our target's here, so our target's 4. We would want to see target is greater than left and less than mid. Same thing with this. So let's do this. While left is greater than right. Let's see. So we want to eliminate this portion of the array because it is less than oh, actually, we just do mid. Okay, so if mid is greater than right, actually, let's do this first. So if nums mid equals target, return. Does it say the index or 0, 1, 2, 3, 4? Yeah, so the index return mid. From here, if mid is less than right, nums right. So if nums mid is less than nums right, so let's look at this. If 7 is less than 2, then I think you would have left equal mid. Then you just recalculate mid. If nums mid is greater than nums right, right equals mid minus 1, mid equals right plus left divided by 2. Okay, so let's just make sure we have both of these right here. Let's do mid plus 1. Because if mid doesn't equal target, then you just, yeah. And we also want to make sure, okay, so if mid is less than right and greater than nums left, greater than nums left. So 4 is less than 7, which is less than 2? No. So what we do then in this case where this back one is wrong, so the opposite. Okay, so if mid is greater than nums right, like in here, and nums mid oh, okay, well, nums mid is greater than nums left. Okay, let me just make sure this makes sense. So we have nums mid, if that's less than right, so that's not the case, just go next one. If nums mid is greater than right, then greater than left, do that. Okay, am I missing anything here? Okay, let's return -1. Okay, let me just make sure. Okay, am I thinking of any use cases wrong here? So let's use the second one. So for the second one, three. So 3 is min equal to 3? No. But if not, what's this? Okay, let's run it, see what happens. Oh. You gotta be careful on how you declare your variables. Okay, so -1 is looking for 0. I wonder if you just included different things here. So nums left and equals target, or nums right equals target, or okay, let's try. Oh yeah, no, that wouldn't work because you gotta return the actual thing. Okay. Okay, so from there, I think I have to add extra conditions. So let's look at this. Let's copy this. Assume it's the opposite way around. Okay, if this left is no, that wouldn't make sense because okay, so maybe I should use the target. So if it's less than or greater than, like look to the left or the right, depending on that. So this one won't ever get run. So yeah, I think you have to use target more. So that basically means that this numsmin is greater or equal to target. I think you want the opposite too. If nums left is greater than target, greater than right. So maybe you should ask if it's in these parameters. So let's do that. So basically, if you split this up, if the target's in here or there, and then you have like the pip value, like where this might be the case. Okay, so is 0 in this? So in that case, if target, or no, if mid is greater than right, that means that you have like an increasing thing to the right, okay? If mid is greater than left, that's normal. Then if left is greater than mid, you have a case like where 7's all the way at the beginning. 7, 0, 1, 2, 4, 5, 6. Okay. And if mid is less than right, I think that you're in normal track 2. Okay. So these special cases, left is bigger than mid, and right is less. So these are the special cases. So if you have a special case, that means the opposite is order. So then all you have to do is make sure that in that opposite case, if the number's in there or in here. So in this case, if mid is greater than right, you have to ask if array, oh, okay. Let me just try to quickly solve this because I think I'm on the right track with this. So if r right is greater than or equal to target, then you are in the correct array. So then what I would do there is left would equal mid, and then, oh, okay, well, mid plus 1 because mid didn't equal that. Then mid equals right plus left, divide by 2, okay, and then you kind of just basically do everything else like that. So in that case, we know that this is in order, so all we have to do there is kind of just copy this. That's normal. And then in this else case, then we do right equals mid minus 1, and then mid equals this. And the reason that we have like this else case is because if this isn't the case, then it's in the opposite side. So then you just want to contract that portion of the array over to the other side. And it would be reversed for this other special case, I believe. So normal, so if mid is greater than left, And then I think we should do elif. So this is the normal one, right? Yeah. So this is the normal. And in this case, what you do is like, hey, boom, okay. So you do an elif here. So for that, then you just do, okay, so this is in the correct range. So now that you want to check is mid greater than target. Then you want this right to be this one. And then you want the other one to be that one. Okay, so you're just like making sure the cases are appropriate. So if mid is greater than right, then you have like a funky case. And then you just do the opposite too. So we'll have a final elif here. So obviously you can make this more compact and beautiful, but I'm just trying to get this to work. So if left is greater than mid, let's do that. Array mid is greater. Well, let's just do like less than target. Okay, so we know mid is less than left. Okay, so if we know mid is less than left, then we should check if mid is less than target. So if mid is greater than target, then this right should go here. Then the left should be an opposite one. Okay, I think this should be a little bit more clear or work. Oh, divide by 2. Nums, okay, nums. Okay, well, I gotta look at this, but thanks for joining me, guys. I'm gonna have to review this to make sure I figure out what went awry, but thanks for joining, and see you next video. Cheers.